Yeah, good evening. And this topic we are going to discuss about the polymers, the fourth unit. Okay, in this fourth unit, here we are going to discuss types of polymers and engineering polymers and commodity polymers. And first of all, I would like to explain what is polymer. Yeah, the polymer, it is the term. It's came from the Greek language, and poly means we know, poly means many, and mer means it's a part. That means many parts. When the many parts when comes together, that is called polymers. For example, you take the hydrocarbons. Hydrocarbons, it is a combination of carbon and hydrogen. Okay, carbon and hydrogen. When you are having a simple H2, CH2, it is called monomer. When you're having the chains of CH2, that means if you're having a chain combination of CH2, it is called the polymers. I will explain the next slide how it is. We call that as a polymers. And this slide we are going to discuss about the simple example and explanation of the polymers. When many molecules of a simple compound join together, the product is termed as a polymer, and the process is called polymerization. Right. When the small parts, like if you're taking, I am going to the next slide for better understanding. Here you are having CH2 and CH2. This is called monomer because this has balanced, like here you having a single bond, and here you are having double bond. That means it actually balanced with these molecules. This is called monomer. There is a no extension link here. That's why we call it as a monomer, and this is the balanced one. Okay, but the next type, the polymer, it is entirely different. The same type of ingredients, chemical components. Here we are using CH2, hydrocarbon actually, and here the hydrocarbon, it is react with another carbon, and react with another carbon, react with another carbon, and the carbon is also react with two hydrogen. You can see the carbon and hydrogen combinations here, but here you have one link to pair another one CH2. Okay, this is the link, and this is the link that can pair with another one CH2. That is called this as the polymer. That is called this is a polymer. That means here you are having imbalanced. That means that doesn't have the balanced structure. Here you are having one more reaction link, and here you have one more reaction link. That's what we call polymers. That means the number of parts when it is comes together, CH2, 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 it is imbalanced when it is comes together. That is called polymer. About the monomer, CH2, that means CH2 and CH2 is both molecules that has the balancing that balancing mutually and balancing each other. There is a no more reaction will taking place with this molecules, but here you can take you can take the reactions, multiple reactions you can take by because of these kind of reactions. In these kind of reactions, I'm moving to the more before slides. Here you can easily understand when many molecules of simple compound join together, the product is termed to a polymer. The CH2 and CH2, it is a simple molecules. The molecules, when it is combination of CH2 and CH2, CH2, it is called polymers. The process is called polymerization. When the process is taking place, that is called polymerization. And the third point is the polymer is a chain of atoms providing a backbone to which atoms or groups of atom are joined. Obviously, the chain reactions which we are having in the before slides when we discussed before, there you are having chains of atoms that providing a backbone. That is the structure giving to the polymers. Okay, if once you are having the structure, you can easily recognize that is called polymers. Okay, This is about the polymer basic explanation, and I'm moving to the next slide. Types of polymers, right? The types of polymers here you are having totally four types of polymers. One is alternating copolymers, random copolymers, block copolymers, and graft copolymers. What is the meaning of alternate copolymers? That means here you are having one type of molecule and you are having another type of molecule, right? For example, this is a hydrogen and this is a carbon, and this is a hydrogen, this is a carbon, and this is a hydrogen, this is a carbon. That means it is alternate. Alternate means order. It is the molecules actually arranged by order. That is called alternating copolymer. This is a first type of polymers, the structure of polymers. And second type is random copolymer. Random copolymer means one hydrogen, again it is carbon, again you are going for three hydrogen, you are going for next carbon. Likewise you are having random polymer arrangement and random molecule arrangement, that is called random copolymers. Okay, this is about the random copolymer. And the third one is block copolymers. Block copolymers, it is very simple, right? If you're having four or five carbon and you're having another set of four or five hydrogen, that is called block copolymers. That is called block copolymers. Okay, this is the third type. When you're having the fourth type, graft copolymers, you're having one hydrogen link, uniform hydrogen link. You're having one way, and on this you're having branches with this. If you are taking this as a hydrogen link, you just take this as a carbon link, or just take this as a carbon link and you are taking a hydrogen link. Likewise you can have the branches. Okay, the branches linked with this carbon, this hydrogen linked with this carbon. Okay, this is called graft copolymers. One is alternating copolymer, random copolymer, block copolymer, and graft copolymer. Okay, these are the four types of arrangement of polymers, right? And I'm moving to the next slide. And previously I have explained the monomer and polymer. Monomer, it is balanced, and polymer, it is not, it is also kind of balanced, but you have the reaction chain that is allowing to going to the reaction chain with the next reaction. Okay, and the next topic is engineering polymers. Okay, the engineering polymers, it's very simple. And this is a group of plastics, and this is a group of plastics material that have improved mechanical and thermal properties. For example, if you are taking a wood, okay, wood is a kind of fiber. Okay, it is not a kind of polymer, and it is a fiber. If you are using a wood, it has more weight and it has more density, but that doesn't have that much amount of mechanical property and thermal property. But in case of if you are using the polymers, okay, if you are using the polymers, it gives a good mechanical and thermal property. Simultaneously you can reduce the density also. Okay, you can reduce the density also. Lightweight and good mechanical and thermal properties. That's why we are going for engineering polymers. Okay, traditionally we are using some kind of things like PVC and all the things. We can slowly eliminate these kind of commodity polymers into engineering polymers. Okay, commodity polymers, it's entirely simple. I'll discuss with the next topic. And this topic we are going to we are discussing about the engineering polymers. Engineering polymers, it's very simple. It is a group of polymers that has improved mechanical and thermal properties. Okay, that can withstand more mechanical load and that can withstand more thermal load. Okay, and these are replacing traditional materials equal to the greater or equal or greater weight, hardness, and or other properties, while being much simpler to manufacture, especially with complex set. Okay, if you're taking wood, if you're taking a wood, you cannot making an exact shape which you want. But in case of polymers, you can make exact shape by using of different type of processing. like if you're taking a hot extrusion process. Okay, hot extrusion process, you cannot do the water bottle by using of wooden material, the fibers. But in case of polymers, you can easily manufacture the bottles and complicated shapes we can use. That's why we're going for the engineering polymers. Okay, in this engineering polymers, we are going to discuss about two different types of, not a types, and examples of engineering polymers. I'm going to the next slide. Engineering polymers, it's a polyamide. We can call that as a PA. 6 is a version, actually 6 we are having, 6.6 we are having. It's not needed actually. Okay, polyamide, it has a common properties, common application. Okay, and it has a good sliding and wear property. Okay, it has good sliding and wear property. That means what? If you're making a contact between any other surface, this polyamide, if it is contact with any other surface, this polyamide will not wear that much comparatively with other polymers. That's why we call this as a good sliding and wear property. Okay, and this is resistant to many oils, greases, and fuels. Very good property. That means it resistant to many oils. That means it will not react, and it will not stick to oils, grease, and fuels. Okay, this will not stick on oil, greases, and fuels. That means if you are taking oil and greases, it is more sticky on the surface. But in case of polyamide, it will not that much reactive with sticky to the oil and grease and fuels. Okay, that's why we are going for the polyamide. For in case if you are using a fuel, okay, if you are taking a why I'm giving this example, if you're manufacturer of fuel tank by using of other polymers. Okay, if it is more sticky with the fuel, what happens? It keeps on sediment over the surface. Some part of fuel actually sediment over the surface, the tank surface. Okay, that is also a kind of the loss which we can attain. Okay, we can eliminate these kind of things by using of this polyamide. Okay, this is about the second point. And third one is high tensile strength. I hope you know what is tensile strength. When you're having opposite for direction force, you are taking a stick. You just taking a stick, you just take this picture a stick. I'm just having a force from this direction to this direction, and also I'm having a this direction. Okay, that is called tensile strength. Okay, it has a high tensile strength. If you are having opposite direction force, this polyamide that can withstand more tensile strength. Okay, and it has a good process. Okay, that means process is very simple. You can easily uh, uh, like restructure, and you can easily mold, and you can easily cast by using of by you can easily cast the polyamide. Okay, that is about the good for processing. And high strength, obviously this has a good strength and good sealing capacity. In why we are going for this sealing capacity? Oils, if you're mating of two metal surface, the mating of two metal surface, in between this, if you're having the polyamide, okay, it has good seal. That means if there is a no leakage will happen between these two surfaces. Okay, there in the engine cases that you can use these kind of polyamides. Okay, and semi-crystalline, I would like to explain the semi-crystalline. What is semi-crystalline? It's very simple. Okay, here you're having one diagram. Okay, one is semi-crystalline and another one is amorphous. Okay, amorphous is entirely different. The arrangement is random. The molecular arrangement is random. It is called amorphous. But in case of semi-crystalline, it has a equal and order arrangement of molecules. Okay, that is the difference between amorphous and crystalline. Okay, I am moving to the application of polyamide, and here the applications are gears, cam, rollers. I hope you know what is the trap power transmission. Cams, it is lifting and lifting for using for lifting process, and rollers, cam and rollers, you know, and bearing, wear resistance. That's why we are going for it has a good wear resistance. That's why we are going for bearing. And nut and bolts, and it has good strength. That's why we are going for nut and bolts application by using of polyamide. And power tool housing, electrical connectors, automotive fuel tanks. I'm already explained the fuel tanks. If you, it is not sticky on the polymer, it will not sticky on stick on the fuel. Okay, it will swipe. It will. This will fall. The fuel is fall down, and it is collected in the bottom. If there is no fuel, it gets waste. That's why we are automobile fuel tanks and kitchen utilitors. Okay, this about the things of the polyamide. Okay, and the next engineering polymer is polycarbonate. Okay, polycarbonate we call simply that as PC. Okay, it has seen excellent impact strength. That means impact. I hope you know what is impact. If you're having the sudden load over the material, that is called impact load. Okay, this polycarbonate that can withstand the impact load. Okay, that can impact load, excellent impact strength it has. And second point is minimum degradation between melting and cooling points. It is very important. Degradation, it is the term, it is called wastage. Okay, if you are increasing and reducing the polymers. Okay, obviously if you are increasing the temperature of the polymers, it gets liquefied. Okay, it gets liquefied and it gets liquid state. Okay, when you're having a when you're going for the cooling process, it again comes to the solid state. Okay, if you're repeatedly, if you're increasing and reducing the temperature, if you're increasing and reducing the temperature, it will not waste. The wastage of material, it's very less. Okay, that's why we call that as a minimum degradation. The wastage of material, increasing and reducing the temperature, it is very less. And it has good UV filtration. UV filtration, ultraviolet filtration. Polycarbonate is that's a good ultraviolet filtration. Why I'm giving this ultraviolet? It is a high wavelength. Okay, ultraviolet, it is a wave. It is a kind of sunlight. You are having UV rays. Okay, if the UV rays which is affected by human, our skin gets burn, our skin gets burned. Okay, that kind of application we can use this kind of polycarbonates. It is a good UV filtration. And the fourth one is can be coated with a scratch resistance protective layer. For example, if you're taking a helmet. Okay, helmet glasses. Okay, there you're using an there you're facing a number of times the resistance, number of time you need to wipe the helmet glasses. On the time the scratches will happen. Okay, on that surface, like that kind of surface, if you are coating this polycarbonate, that resists the scratch. Okay, that is a one type of property. And the application of polycarbonate, it is a Polycarbonate is often to use the aircraft parts. Okay, aircraft parts we can use, and it is a data storage device we can use, and eye protection components. I'm already explained because it is a UV filtration and electronic components. Okay, these all are the application of polycarbonates. And thanks for watching this polymers and engineering polymers topic. Thank you, and we will meet another one video with the commodity polymers. Thank you.